by the name of the god. Design of water structure. Lock structure. Hydraulic and structural design. Hydraulic calculation, design of site culverts. The purpose of the hydraulic calculation step for the lock is to find the dimensions of the site culvert responsible for filling and emptying the lock chamber. T, capital time to fill and empty lock chamber. T small, time to fill and empty the gate side culvert. 2 in 2 minutes. T, we tell about that, T small, yeah. A, lock chamber space or lock room space. A small area holds for side culverts. Its maximum is a different level between upstream and downstream. Look structures. Mean culverts, there is X and Y. We can calculate from A and Y. Minor culvert, the same. There is X1 and Y1. We can calculate from a minor culvert like that. Structural design. Guide pier is designed or generalized in symmetric locks only. Dimensions, something like that. HW, that's appear in drawing. B capital, it's appear in the drawing. Loads W, vertical. E, horizontal loads. W is the load for the weight of the construction. E, the water pressure. Lock structure, check sliding, factor of safety, mu multiply N over T capital, is bigger than or equal to mu, is a coefficient from 0.5 to 0.75, N capital equal G, W capital, T capital equal E. Check overturning, factor of safety more than or equal to, and there is equation for SM OTM, something like that. Check of stress for section 1 and 2 or side 1 and side 2, minus N over A multiply 1 plus or minus 6 multiply E over B. F1 or 2 compression less than or equal 40 kilogram per square centimeter. When designing a section of the wall with opening for the lateral culvert, when finding the stress hole at the connection of the wall to the base, F1 and 2, there is stress, there is B and X and A. This is the shape of the stress, F1 and F2. If there is a hole, something like that, it will be like that. Landing wall, We make a dimensions for h small w, height, b small width in the upper, b small width in the down, y dash it's appear, something like that, y side culvert height, x side culvert with height. Check sliding factor of safety is more than or equal 1.5. Check overturning is more or equal to check of stress. The same equation is minus n over a phi 1 plus or minus 6 multiply a over b. There is a and x dash and e, eccentricity. The forces is something like that from water pressure, from soil, from weighting of or weight of constructions and soil. Stress distribution, something like that if there is a wall opening. If there is a hole, it will be something like that. Flower wall and gate structural design. It is assumed when designing that it is designed like the base of the weir, but due to the length of the locked chamber, we find that this direction is safe against phenomenon of pipes, and therefore it is not designed with the base of the weir. Look the stress under uh, uplift pressure, something like that. We can find the depth, design depth. We can design as a concrete, something like that. D equal Q1 multiply M capital moment over B under square under 0.5 root. Trust this wall, something like that for all dimensions, for every components like that, and when the gate is closed, there is a law we can calculate due to water pressure in upstream and downstream, something like that. Last wall, there is a theta or phi here to calculate the distribute of forces due to that. Last wall, we can calculate F1 and F2 in the last. Compression less than or equal 40 kilogram over centimeter مربع, and 40 kilogram over square centimeter. For opening gate, another positions, the force will be different. Gate will be, I will have a weight is 0.35 for square meter from gate. Look structure, look the forces F1 and F2 less than or equal 40 kilogram over square centimeter. And this is the shape for F1 and F2.